debate ends now. Loeb just published calculations showing exactly how to prove whether Atlas is ice or engines. And the test is so simple, it's devastating. Natural comets can't push gas beyond 5,000 kilometers from the nucleus before solar wind stops it completely. Atlas's anti-tail extends hundreds of thousands of kilometers. If gas is flowing out there with the dust, the comet theory collapses instantly. And we're about to find out because telescopes can detect streaming gas molecules and measure exactly how far they reach. No more speculation, no more interpretation, just physics that distinguishes between thermal sublimation at 200 meters per second and rocket exhaust at thousands of meters per second. This is the test that settles everything. Follow right now so you don't miss Atlas updates. Here's the physics. Natural comets sublimate ice when sunlight heats the surface. Carbon dioxide molecules at 200 Kelvin surface temperature, which is what Atlas experiences at twice Earth's distance from the sun, reach thermal speeds of about 200 meters per second maximum. That's basic thermodynamics. You can't get faster gas flow from natural sublimation at those temperatures. The molecules have a specific thermal energy, and that energy translates to a specific maximum velocity, 200 meters per second. That's the ceiling for natural outgassing at Atlas's current location. Now factor in the solar wind. At 2 astronomical units from the sun, solar wind flows at 500 kilometers per second, carrying mass density of about 3.10 to 24 grams per cubic centimeter. That's a constant blast of charged particles moving 2,500 times faster than the thermal gas speed from natural sublimation. When slow-moving comet gas meets fast-moving solar wind, the wind wins. Ram pressure balance calculations show that gas moving at 200 meters per second gets stopped at approximately 5,000 kilometers from the nucleus. The solar wind sweeps it up and carries it backward along the tail away. From the sun, 5,000 kilometers. That's the maximum distance natural comet gas can travel before being pushed back. And here's the critical observation. That 5,000-kilometer radius roughly matches the size of the glowing coma around Atlas's nucleus in every image we have, including Hubble Space Telescope high-resolution observations. The bright, fuzzy region extends about 5,000 kilometers, exactly where solar wind should be stopping natural gas flow. But the anti-tail extends hundreds of thousands of kilometers beyond that. Recent images from December 27th show the anti-tail stretching 1.1 by 1.8 million kilometers. That's not 5,000 kilometers. That's 200 times farther than natural gas can travel before solar wind stops it. So what's creating that massive extension pointing toward the sun? If Atlas is a natural comet, the answer has to be dust only. Large dust particles around 10 microns get dragged to hundreds of meters per second by the gas near the launch base, then continue traveling through space on momentum even after the gas gets swept away by solar wind. Solar radiation pressure eventually slows them down, but not as quickly as it stops gas. So a natural comet could have a 10-micron dust stream extending hundreds of thousands of kilometers in an anti-tail, while the gas only reaches 5,000 kilometers before being pushed back. That's the natural explanation. Dust without gas beyond 5,000 kilometers. And here's why that matters. We can test it. Spectroscopy can detect molecular tracers like carbon dioxide and carbon monoxide. Tag those molecules along the axis of the anti-tail and measure their spatial profile at different distances from the nucleus. If gas stops at 5,000 kilometers and only dust continues beyond that, Atlas is natural. If gas is streaming out to 25,000 kilometers, or 100,000 kilometers or farther, the thermal sublimation explanation fails completely. Chemical rocket thrusters produce exhaust at 5 kilometers per second. At that velocity, ram pressure balance shows gas can reach 25,000 kilometers before solar wind stops it, 5 times farther than natural sublimation allows. Ion thrusters reach exhaust velocities of 90 kilometers per second, which pushes the stopping distance out to 100,000 kilometers. 20 times farther than thermal gas from ice sublimation. The test distinguishes them definitively. Measure where the gas actually stops, and you know what's producing it. No ambiguity. No interpretation required. The physics gives you the answer directly. Ground-based telescopes like Keck, VLT, and ALMA can perform this observation. Space observatories like SphereX and Webb telescope have the spectroscopic capability to detect carbon dioxide and carbon monoxide molecular signatures and map their distribution along the anti-tail. The data exists or can be collected easily. We just need someone to actually do the measurement and publish the spatial profile showing how far streaming gas extends. If they find gas at 25,000 kilometers, that's chemical propulsion. If they find gas at 100,000 kilometers, that's ion drive technology. If gas stops at 5,000 kilometers and only dust continues beyond that, maybe the natural explanation survives. But every image shows that anti-tail extending hundreds of thousands of kilometers. And if gas is flowing out there with the dust particles, there's no natural process that explains it. This is the definitive test: natural ice or technological engines. 5,000 kilometers or 100,000. The answer is waiting in the spectroscopy data that proves what ATLAS actually is.